go stretch, reflect, translate. Remember I told you you could go RST like the alphabet, reflect, stretch, translate, only because reflect and stretch multiply, and translations add and subtract. So you're doing order of operations. That's why they're in that order. Okay? There's always someone who doesn't listen to me and writes translations first on the test and gets it wrong, and then are mad at me, and I'm like, I have no idea why you're mad at me, so I just kind of like walk away. Because I have to walk away, you have to walk away, and then your usual classmates are often like, she said, this, you're wrong. And then I'm like, you know. All right, so the A, if we get into y equals, and we have a 1 in front of our x, the A is a vertical stretch by a factor of A. If A is negative, then it's also a reflection in the x-axis, right? And the x-intercepts are invariant. The x-intercepts are invariant because that's where y equals 0, correct? So if all we have is stretches and reflections happening, then our x-intercept and y-intercept will be the invariant points. Because stretches and reflections multiply. And you multiply 0 by a number, it stays 0, which means it's not going to change, correct? So when only stretches and reflections happen to the y's, your x-axis remains invariant. When only stretches and reflections happen to your x, your y-axis remains invariant because your y-axis is where x equals 0, correct? And we're applying it to only the x's. So same thing here, x equals 0. Now remember, a horizontal stretch by a factor of 1 over b. It always switches when we go from equation to words and mapping, correct? Words and mapping are in a heart. It stays the same, yes? Okay. Horizontal translations, if h is greater than 0, it's to the right. If h is less than 0, it's to the left. I'm talking about h, not the sign in front. So if h itself is greater than 0, it goes to the right. When we have a plus sign in the middle, it's minus a minus h, correct? So it would go to the left. That's why h's are opposite. You can also just remember that your equation, x is be crazy. So if you go from equation to words and mapping, your x is switched, correct? If you sit in the words and mapping heart, it just stays what it is. All right? And then your vertical is what it is because y's are awesome. Okay. When graphing, create a table of values from the original and use mapping, right? Graphing or moving a coordinate, mapping should be what your head thinks to do. All right? Okay. Describe how the graph of each of the following functions can be obtained from the graph of y equals f of x. We should throw a party in our heads. The original graph is y equals f of x, which means it's any function in the world that has not been moved. So anything that they give us now is new and a transformation. Yes? Okay. And then state the mapping. So you guys are going to try this out. Before you start any question, there are two things that have to happen if you have an equation given to you. The equation has to be in y equals, that's number 1. And number 2, there has to be a 1 in front of the x. If that is not the case, we have to do those two things before we start. Okay? Try it out, use pencil. It might be a little rough at first. 1. Is it in y equals? Yes. Is there a 1 in front of the x? Yes. Remember I told you the case where the 1 doesn't directly have to be in front of the x is when no horizontal translation is involved, because technically you could just write the horizontal stretch in front of 1x, right? Like there's no, that doesn't make a big difference. Okay, so we're going to go from equation to words and mapping. Words and mapping are in a heart. And this is my equation. So my x is be crazy because I'm going from equation to words and mapping, correct? But once I get words or I get mapping, I can just stick with what I have because they're in a heart. Yes. Okay, let's test and see. So this half is in front. Nothing is with my x's, so no x is to be crazy. This is the best question ever. So we have a vertical stretch. By a factor of 1/2 above the x-axis and a vertical translation 2 units down. Now what's awesome is it's half and -2. My mapping will be the same, a half y minus 2, right? Y's are awesome. So we get x, y becomes x, comma, 1/2 y, minus 2. Okay, we're going to discuss this. It's a side caveat. Ready? Because this is where people stink. in this math lesson. I'm going to give you the domain and range of the original as well. We're going to discuss it as we go along because it's overwhelming, so I didn't make you do it before. But I'm going to tell you that f of x has, this is just for f of x, has a domain I'll do set notation for this one, just to make it a little easier. So it has a domain from that's an eraser, -2 to 4, and it has a range from 0 to 8. Okay? What is my new domain and range? That's what we're going to talk about. What is my new domain and range? So remember, x's affect domain, y's affect range. If you don't remember that, domain x, I draw a line, nothing crosses. Range y, I draw a line and there's 2 tails. You're welcome. Now you know. That domain x, no, nothing goes below line. Range y, both have a tail. I'm so lost. If I go domain and y, tail, no tail. Yeah! All right, we're there. I hope you just know it, but you know. All right. So what affects my domain here? What affects my domain? Nothing. So wouldn't this be the absolute best question if they just asked for the domain of the transformed function? Yeah, it would just be -2, 4. It doesn't change. Nothing happens to my x's. You guys stink at that question. You're like, must have change. Can't be same. No, it can. So the domain of this one would be -2, 4. Nothing happened to it. True? Okay. Range, what's happening? Guess what I get people doing? Paying attention? I get people taking the domain, -2, 4, putting it in for the coordinate, applying it. Then I get them taking the range, 0, 8, putting it in for the coordinate and applying it. Is that correct? No. Range is 2 y values, correct? So I'm going to have to put the 0 into the y of mapping, and then put the 8 into the y of mapping. We agree? Okay. So if I put the 0 in, I'm going to get 1/2 0 minus 2, which equals -2. And then I'm going to get 1/2 times 8 minus 2, which is 4 minus 2, which is 2. These always go low to high. Now think about this. If it reflects, your negatives are going to become positive, your positives are going to become negative, the numbers are actually going to flip. Now, if you forget that, just remember, when you state domain and range, it has to go low to high, correct? So if my result would have been like 2 and -4, I wouldn't write 2, -4. I would write -4, 2, because I know they have to be in order. Yeah? Okay, so the range now is -2 to 2. We agree? X's affect domain, Y's affect range. Use the X of mapping to apply to the domain. Use the Y of mapping to apply to the range. What if the range was YER? So every Y value existed. Does any transformation change that? No. So when your domain or your range is XER or YER, it doesn't matter what you apply, it will stay the same. So that's another one that tricks people out. So if I had given you, the domain was -2, 4 and the range was YER, and then I gave you a question, everyone paying attention, and they gave you multiple choice options, and I would say the domain stays the same, the range stays the same. B, the domain stays the same, the range changes. C, the domain changes, the range changes. D, the domain changes and the range stays the same. Like all the 4 options. If my original was -2, 4 and YER, the domain and range would stay the same. The domain would stay the same because nothing affects my x's, and the range would stay the same because it's YER and nothing's changing. Right? So you have to watch, because just because things are affecting the y or the x doesn't mean the range of domain change if it's y, or x. Yeah? Okay. B, we're in y equals and we have a 1 in front of our x, so we can talk. So we have a vertical stretch, so this affects my x's, and then these affect my y's. The outside ones, you can draw a y if you so choose. So this is going to be a vertical stretch by a factor of what? 3. About the x-axis. What does the negative do? Reflection in the x-axis. And faster. Okay, and then a horizontal translation. Yeah, I'm old. We did handwriting in school, a lot of it. Horizontal translation. 5 units, what? Right. The only thing I don't write correctly is the capital Q, which is a Q. Because that looks stupid. All right. Like queen. That's queen. Or tween in my head. It's a Q. That is a Q in handwriting. Okay. So, mapping x, y becomes, I need to go 5 right. So I'm going to go x plus 5, and then I'm going to go negative 3y. We agree? Okay, now let's talk about that domain and range. So, are my domain and range changing this time? Yes, because things are affecting my x's and my y's, and neither my domain or range is at CR1. Correct? Okay, so if I want to do my domain, I'm going to add 5 to it, right? Because that's what's happening to my x's. So, I have negative 2 plus 5, which is 3, and then I have 4 plus 5, which is 9, and so my new domain is 3, 9. Okay, then my range, I'm going to go 0 and 8. Negative 3 times 0 is 0. Wait a second, that stayed the same. Why did it stay the same? Because it's 0 when we multiply. When we multiply by 0, it's not going to change, aka the varying point will be there. Yeah. Oh, and our y is 0. Okay, and then negative 3 times 8 is negative 24. So it's substantially stretched. Range. Wait a second, I'm going to go 0 to negative 24. Because that's the order in which they came out. Yep, cool, good, great. Mrs. Lepp's going to cry, but it's fine. It's totally okay. What should it be? Negative 24 to 0. Remember, it reflected in the x-axis. So your highest point is now going to be your lowest point, and your lowest point is now going to be your highest point. So when it reflects, your inequality signs are actually going to flip. You're dividing by negative 1. When you divide by negative, your inequality sign flips. So, oh, please don't tell me that that was the first time. Okay. When you divide by negative, your inequality sign flips, right? Which is why they flip. All right. C, our problem. We don't have a 1 in front of the x. So we take negative 2. When we divide it out, negative 2x divided by negative 2 is 1. And then 10 divided by negative 2 is minus 5. Yeah? All right. So, if we forget to do that, our horizontal translation will be wrong every time. Yes? Do you think the answer will be on the test? To the wrong one. It will absolutely be there and often pick more than the correct one, which makes me a little sad. Okay? This still all affects my x's because it's still with my x, and if you don't believe it, when I put the negative 2 back in, it goes with the x. It doesn't go with the y, right? So it's still with the x. A lot of people think it changes. It doesn't. So the only thing affecting our y's is this 4. So we have a vertical stretch. By a factor of what? 4. About the x-axis. My X looks like an A because I didn't pick it up. Okay. Do we have a horizontal? Yeah, we have a horizontal stretch. By a factor of what, guys? 1/2, because going from equation to words and our X's be crazy. And not negative, because that's not a horizontal stretch. About half that, about. Oops, y-axis. Okay, what does this negative do? Reflection in the y-axis. And then we have a horizontal translation. Ooh, that's really dicey. If this was you first learning, I would not be writing this in messy fashion, but I don't care right now. Translation, 5 units. Right. Okay, our mapping. X, Y becomes, if I'm going from equation to mapping, it'd be crazy, right? So I used a half and negative in here. This is also -2, so in mapping it's going to be -1/2. X plus 5, no brackets in mapping. And then 4y. Okay, let's discuss our domain and range. So our domain is going to be multiplied by a half and add 5, and our range is going to be multiplied by 4. So we're going to have -1/2 times -2 plus 4 plus 5 equals -1/2 times -2 is +1 plus 5 is 6. And then we get -1/2 times 4 plus 5 equals -1/2 of 4 is -2 plus 5 is 3. So weirdly, I have 6 and then 3. I have to write it as 3 and then 6. Does that make sense that that happened? Yes, because there's a reflection. Correct? Okay, my range, I'm going to multiply by 4. So that 0 is going to stay the same. So I'm going to get 4 times 0, which is 0. And then I'm going to get 4 times 8, which is 32. 0, 32, it's correct. Why didn't they flip? Because they didn't reflect. Yeah. Okay. All right. Then you're going to flip over. You guys do okay on that one? Flip when you should, keep when you should. Does the domain and range thing make sense? Yeah? Good, because they'll give you ones with variables. All right. Example 2, example 3, example 4. We'll do just, we'll do 4 and 5. We'll do 4 together because I have to explain what a graph that gets you full marks looks like, and then what you guys do. Yep, just leave your phone behind. Okay, work on 2 and 3. Go. Example 2, we're moving a point. When we move a point, we move many points, which is a graph. What do we use? Mapping. Every single time. It's on the curve y equals f of x. We throw a little party in our heads. It's a nice basic function. Best thing they can give us. Correct? Okay. Describe how the transformations affect the ordered pair. If this is the transformation, then determine the transformed coordinates. So we have to first describe it. But before we do any of that, we have to make sure it's in y equals, and there's a 1 in front of the x. Currently, there's a -1. So we get 2f, take out a -1, x minus 3 minus 1. Correct? Let's talk about our transformations. This affects x, this affects y's. Correct? The outside affects y's. Okay. So, start with our stretches first. Vertical, stretch, by a factor of what? 2 about the x-axis. So it's about the opposite one it affects. Okay, then we have a -1 with the x. So that's a reflection in the y-axis, which would change the domain. And if there was inequality signs in my domain, it would change the domain to flop, correct? It affects my domain. All right. Then I have a vertical translation. 1 unit what? Down or up? Down, because y's never changed. And a horizontal translation, I'm going from equation to words, so it goes across the double-headed arrow, so it's going to switch. So horizontal translation, 3 units what? Now, if I go from equation to mapping, my y's stay the same, my x's will flip, right? So sometimes people like doing words and then doing mapping from it because it just directly correlates. Some people are like, I just know from equation to mapping it switches. So whatever way is best for you, do that. But you could be given different forms. So if I go to mapping from equation, my x is going to be -x plus 3. Because it's going to be the opposite. If I go from words to mapping, it's a reflection in the y-axis. It's a -x, 3, right? I add 3, right? Same thing. Y's don't change. So it's 2y minus 1. And then I apply my coordinate, the m and the 3n, into that. So I'm going to get m, comma, 3n becomes, now this one I plug right in because it's a coordinate, correct? When it was domain, I took each x and put it in for the x's of the mapping, right? When it was range, I took each y, put it in for the y's of mapping, right? Domain and range are different than a coordinate. A coordinate, you just plug it because it's an x and a y, yeah? But domain is an xx and range is a yy. All right, so we get -m plus 3, and then 2 times 3n minus 1, and we can make it look better. So it's -m plus 3, comma 6n. Example 3 says the graph of y equals x cubed. So now is this f of x? Can I just use f now in my equation and just use an f because I want to? Is there an f even in this? No. So you can't use f of x unless I give you f of x to your original, correct? So this one is y equals x cubed. Yes? Okay. So we have to apply it to that. So y equals x cubed is, and this is something that might help you guys, is to literally go like this. So that bracket, I put it around my x, and it is cubed. Yes? So anything that affects my x needs to go into that bracket and get cubed. Anything that doesn't affect my x needs to sit in front, yeah, of that bracket. So it's stretched vertically by a factor of 3. So I'm going to get a 3 in front of that bracket. Reflected in the y-axis, does that affect the x or the y in the y-axis? It's x's, right? It's reflected in the y, has to affect x. So I know it's going to be in the bracket. I'm going to get a -1. And then I open up my brackets again. Cubed. Translated 2 units left. So I have to go x plus 2. Do you see how I have that extra bracket in there? Why do I need to have that extra bracket in there? Because I need to have a 1 in front of my x before I can say the translation. Yes? So I can't go -1 x plus 2 because then I could take the negative out and it would actually be x minus 2 and I'm going 2 right. So it's bad. So when you do x's and x's only, whether it's a stretch or reflection, put it in front and then open a bracket to put in your translation. Okay? But only for x's. And then 4 up plus 4. And then we need the mapping notation. xy becomes -x minus 2, 3y plus 4. So we're only going to look at the first graph on example 4 because it's a quadratic. The bottom one is a radical. I'm not going to make you move a radical right now at this moment because you don't even know what a radical is, and it's one of our last 5 lessons of the year. So we're going to look at A first. So we need to move y equals x squared, and then we're going to move it to that. Now some people might say, well, Mrs. Lepp, it's easy because I can just type that in, right? What I could do instead is I could have said f of x equals x squared, and then g of x equals 1/2 f x plus 4 minus 5. Could I not? No, it's not squared, it's an f. So this is just saying that I'm applying 1/2, the 4, and the 5 to f of x, which happens to be x squared. So you see how this one doesn't have a squared in it? F will never have squares in it. It's going to be the number of the stretch, f, the number of the stretch, minus the translation. Okay? They mean the same thing. This is just your original, and you're applying that to it. Now what they could do instead is they could say f of x, y equals f of x is shown below, so I could give it to you. 0, 0, 1, 1. Negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. Okay. This is correct. Can we all put your pencils down? This is what I get. You know that if this is all the points you have, you can go about 1.5 blocks up and draw your arrows and you have to stop? Not you. You do this. I believe it's up here, and I'm going to send it up here. The only part of your graph that is accurate is this little piece. The rest of your graph, for lack of better words, sucks. It has no accurate coordinates. Yes? So think about it this way. Wherever I draw coordinates, I can draw an arrow about 1.5 blocks past. If I don't have more coordinates, that's all the graph I'm going to have. Do you think they're going to want a little teeny tiny graph on a large graph? No, they're going to want the whole thing. So what does that just mean for you? You need to get more coordinates, correct? Which is what I had in the first place. So that's why we do 2, 4, negative 2, 4. Then if I stopped here, my arrows could only be about this high, right? Just a little above. So I'm going to keep going. 3, 9, negative 3, 9. And now I can actually sketch it. Do you see how my line looks like this? My line doesn't look like this. Like it looks like you rode a bus and you just went over 4 speed bumps while you were trying to draw the graph. Okay? Because that's not accurate. Try your best. Okay? So how could I move that graph if they had just told me that this was f of x? If they just said this is f of x and now g of x does that, draw g of x, what would you do? Can't type it in your calculator, so you'd have to use mapping. Yes.
Good job, Ian.
Good job, Ian. Okay, so we would have x, y becomes, this affects my x's, it's 4 to the left. So I'm going to go x minus 4. And my y is going to be 1/2 y minus 5. And then I use all my coordinates, and I'm going to plug them in, correct? So I use coordinates sequentially so that I can apply them, give it x1, connect. Yeah?
Don't you have to put like the y scale and the x scale?
Yes. So my point was if I gave you this graph filled in.
Oh.
If you were drawing it, we would have to have what?
X scale 1, y scale 1.
Does it have to be 1?
No, whatever you want.
It can be whatever you want it to be. That means that you have to tell them what you wanted it to be. Very good. Okay? So, we have negative 3, 9. We have negative 2, 4. We have negative 1, 1. We have 0, 0. 1, 1. 2, 4, 3, 9. I'm going to tell you right now, the way that Math 30-1 is easier is if you know what the parent functions of all the functions we talked about looks like. So I can give you a random function that isn't anything normal. But as we go through the units, we get different specific functions. So next unit is polynomials. So the graphs we're going to look at are linear, quadratic, which is grade 10 and 11. And then we're going to do cubic, quartic, quintic, degree 3, degree 4, degree 5, which sounds excessively hard. It is not. I have to stop at degree 5. I'm not allowed to give you anything higher than that. Okay? So we need to know what the basic linear function looks like. Quadratic, cubic, quartic, and quintic. Those are called the parent function. Like this is the parent function of the x squared graph, right? Then we move on to trig. So we're going to need to know the parent function of the sine graph and the cosine graph and the tan graph. Then we move to exponents and logs. We need to know the parent function of the basic log graph, basic exponential graph. And we move to rationals, parent function of that. Radicals, parent function of that. Yes? If you know those basic parent functions, they often move those. So it does make it a lot easier for you to visualize. All right, so let's apply it. So we're going to get -3 minus 4, 1/2 of 9 minus 5. So we're going to get -7, and 1/2 of 9 is 4.5 minus 5 is -0.5. 5, 6, 7, and -0.5. All right. Okay. Then we're going to get -3 minus 2, 1/2 of 4 minus 5. -3 minus 2 is -5. 1/2 of 4 is 2. 2 minus 5 is -3.
Sorry, can you please do that?
1/2 of 4.
Sorry, I meant the x value would not be -2 minus 4.
Why did I put a 3?
I don't know.
Bueller? Bueller? Because I wrote this one.
Oh.
And if you think that that doesn't happen, it happens because you're just aimlessly doing stuff. So this is -2. Always go back up here, -4, which is -6. It's there the whole time. I don't know what you're talking about, Nika. Totally wrong. Okay, let's try this again. Oh, my point's here too. I can't even sell it. Okay. -6 and -3. Okay. And then we have, I have to go back up here. -1 minus 4, comma 1/2 of 1 minus 5. So we get -1 minus 4 is -5. 1/2 of 1 is 0.5. 0.5 minus 4 is -4.5. And then 0, 0 is my vertex. So it'll still stay my vertex. 0 minus 4. 1/2 of 0 minus 5 becomes -4, -5. So then I can only do that, right? A little bit past after my arrow. I can't just shoot it off to whatever my heart feels. Less. Okay, then we have 1, 1. 1 minus 4, and then 1/2 of 1 minus 5. So it's going to be -3 and -4.5. Symmetrical. Does that help? So here I'm going to get 2 minus 4, comma 1/2 of 4 minus 5. So I'm going to get -2 and -3. And here I'm going to get 3 minus 4, 1/2 of 9 minus 5. Becomes -1 and -3. and a little past. Make sense? So can I just make that arrow just shoot all the way off? No. Because actually, this graph transformed to this would get me full marks. If you add just some random arrows to the end, you lose 0.5 because you just made your graph that was perfectly accurate crap. Right? Because then this would be the accurate part because of the points, and then these arms are just like, you just went with like how your heart felt. I'm just gonna, yeah, that's how. Okay? Then we're gonna flip over. So this is a radical graph. We're not going to go over the parent function of a radical graph. We speak a lot about in 9 and 10. So I could ask any questions about it, but I won't make you graph it on it. But I can ask anything about it. In order to tell the transformations of this one, I would have had to take a -1 out, right? First. Okay. Okay. Example 7. Example 8, go. Guys, I didn't know there was a 5 and 6. It skipped it. 5, 6, 7, 8, go. So, we are moving a graph. When we move a graph, we use mapping because we're moving coordinates. So our mapping, before we do that, we make sure it's in y equals and there's a 1 in front of the x, if there is. Our mapping is going to be xy becomes x plus 3, because equation of mapping is opposite, minus 2y plus 1. Y's always stay the same. Our first coordinate is -3, -2. It's going to become -3 plus 3, comma -2 times -2 plus 1. So it's going to be 0 and 5. Okay. Then we have -1, 0. It's going to become -1 plus 3. -2 times 0 plus 1. Which becomes 2, 1. Peanut gallery. So, okay, between this point and that point is a straight line. Yes? So between this point and this point will be a straight line. Then that's straight. Okay. Then we have 0 and 4. Is going to become 0 plus 3, comma -2 times 4 plus 1. So it's going to be 3 and -7. Now this one actually goes up and rounds and comes down, right? So we're going to get to it and then round it a bit. As long as it rounds. The next one is 2, 0. Which becomes 2 plus 3, -2 times 0 plus 1. Which becomes 5, 1. And then, that one's going to round 0. And then we have 3, 5. A little past 5, but on a diploma they'd be accurate. So it'd be 3 plus 3, 2 times 5. So we get 6 and -8 peanut gallery. You're getting louder, peanut gallery. Peanut gallery is the table. It's -9. 6 and -9? That's what I have. Remember when I talked and said peanut gallery?
Yeah.
I get distracted really easy and then I start making mistakes and you guys start talking at the peanut gallery as it gets louder and louder. I make more mistakes. Point proven. I get like frustrated, my anxiety is over here and then my anger is like up here and then my math is like here.
Correct.
Okay. 6 and negative 9. Yeah. The next one wants the equation and then mapping. I want to go over these ones specifically because the equation people do wrong. Because of horizontal stretch and reflection, they don't write out in front and then go brackets with their translation. They try and write them together and you get your translation wrong. Okay. So here we have a horizontal stretch by a factor of a quarter. I'm going from words to equation. What's going to happen with my x? It's going to flip, so I get a 4. And then a vertical translation 5 down. So I actually don't need brackets because there's no horizontal translation, right? Minus 5. And then words to mapping is the same. So I have a quarter, I'm going to use a quarter. I get 1/4 x, y minus 5. So I'm not kidding, the words mapping heart to equation does help. Because if you get stuck, think, am I going over that double-headed arrow? If I am, my x's are flipping. Yes? If you can get yourself to flip when you're supposed to and not flip when you're supposed to, then you get the questions all right. It's crazy how that works. You're doing it correctly. Okay? B is a vertical stretch by a factor of 3/5. Verticals never change. A reflection in the y-axis, -1. And a horizontal translation to left. Tell me if I'm right. That would actually be 2 left because I have to take the -1 out. It would change it. So what do I need to do? Brackets. Now am I right? Yes. Now I'm correct. So remember, when there's a stretch or a reflection with the x, you have to put it in your equation, and then your translation goes in brackets. Because when I'm done with my equation, I need to have a 1 in front. Now, what they do sometimes is they give you a multiple choice answer where there aren't the brackets, correct? But you will always do the brackets first, and then if you don't want the brackets, what do you do after that? Distribute it in. Okay? We'll talk about the other 2 examples tomorrow. Your homework today is what do you think? The combined transformations homework.